So in this question, we've got a car of mass 950 kilograms, puts on its brakes and reduces its speed from 25 meters per second to 15 meters per second. Now, the constant retardation force as it's applying its brakes is 2,850 newtons. What we want to know is, what distance did the car travel during this deceleration period? So, first of all, let's draw a forces diagram. Now we can assume the car is driving along a straight road and all things normal as per driving a car. So this line can represent the road. We'll have this little block here can represent the car. I'm not going to draw a car. And 950 kilos is the weight of the car. Now, the retardation force when it's applying the brakes is 2,850 newtons. So let's assume the car is travelling in this direction. So let's just put a little arrow there to represent the travel of the car. Now, if the car is applying the brakes, then the force is going to go in the opposite direction. So the braking force, let's put that as the brakes. That one there is 2,850 newtons. Okay, right. Now, the other forces that will apply there is the forces of gravity. So we'll have the force acting downwards on the car, which would be 950 G. So 950 newtons times the force of gravity. And the force in the upwards direction will be the normal force. Okay, right. Now we want to find, first of all, what's going on with this car. So first of all, what's the acceleration of this car as it goes from 25 meters per second to 15 meters per second? We need to calculate that. So what we can use is Newton's law of motion, force equals mass times acceleration. So force equals mass times acceleration. So if we want to resolve in the direction the car is travelling in, so we resolve the forces in this direction, then what we'd have is, we have this 2,850 newtons, 2,850. Now notice as we resolve it in the forces in this direction, this braking force is going in the opposite, so that's going to be minus 2,850, and that's going to equal the mass of the car, which is 950, times the acceleration force. Okay, now what's the acceleration force? Well, if we just solve for A in this equation, then we get what A is. So we will have A equals minus 2850 divided by 950. So therefore from that, divide that through, 5's into that, 95's into 285, there's 3. So therefore acceleration equals minus 3 meters per second squared. So that's our acceleration force. Now that's only part of the solution. We still haven't found out the distance. So for that we could use one of the SUVAT equations. So let's have a look at maybe this one. So we've got our initial velocity, which is 25 meters per second. We've got our final velocity, which is 15 meters per second. We know the acceleration, so that's this one, that's fine. And we want to know what S is. So that's our displacement. So how are we going to find out that? Well, one of the SUVAT equations, which we know involving A, S, U and V, is we've got V squared equals U squared plus 2AS. We know what V, U and A is, so we solve for S if we plug in the values into here. So V is our is our final velocity, which is 15. So 15 squared. U is 25. So that's 25 squared plus 2 times our velocity, our acceleration, which is minus 3 times S. Okay, well 15 squared is 225. 25 squared is 625. And then 2 times minus 3 is minus 6 times s. So we've got minus 6s. Okay, let's subtract 625 from both sides. So we've got minus 400 equals minus 6s. So divide both sides by minus 6. So divide by minus 6, divide by minus 6. We'll get s equals 200 over 3. Now that's our displacement. Now our unit is in meters. So our displacement is going to be 200 over 3 meters. So s equals 200 divided by 3 meters, which is the same as 66 2/3 meters. So that will be the answer to our question. Okay.